In 11.3, we're going to talk about rates of change. We're going to start off by talking about average rate of change, and then we're going to lead into talking about instantaneous rate of change. Now, one of the main applications we use calculus for is determining change, either an average rate of change or really an instantaneous rate of change if we can find it. So maybe a market manager wants to know the profit change with respect to the amount spent on advertising. Or a doctor wants to know a patient's reaction to a drug change with respect to the dose. We want to figure out change over time, or average rate of change. Another example, let's say we were traveling to San Francisco. Every half an hour, we note how far we had traveled, so our distance, with the following results for the first 3 hours. We can figure out our average rate of change, our average speed, if we can figure out the distance over the time. So for example, we can figure out our average speed from when we start to t equals 3 hours. I can figure out how long I drove in the 3 hours. I can figure out my distance. Starting at 0 and going to 138, I can figure out the total distance traveled. That's 138 minus 0, or 138. Over the total time period, which was 0 to 3 hours, that's 0 minus 3, or 3 hours. So then I can say, by dividing, that my average rate of change, or my average speed, was 46 miles per hour. Now it's not my instantaneous rate of change, but it's my average rate of change, my average speed over those 3 hours by using the information up above. Now we can actually use this formula to find the average rate of change for any interval, or average speed for any interval on the trip. We can use it if we wanted to figure out our average speed from 1 hour to 2 hours. We can figure out our distance traveled, 104 minus 55, over the time traveled, 2 hours minus 1 hour, or just 1 hour. If you've noticed, I'm really just doing a y2 minus y1 over x2 minus x1. You've heard of that before, right? It's just the slope between 2 points. So we can actually find the average rate of change by using our slope formula. So our average rate of change is actually just finding the slope between 2 points. I can figure out my y2 minus my y1 over my x2 minus my x1, the average rate of change from one point to the other. So anytime you hear that word average rate of change, just think about finding the slope between the 2 points, y2 minus y1 over x2 minus x1. Let's do an example. Example number 1 says the United States population is becoming more diverse. Based on the U.S. Census population projections from 2000 to 2050, the projected Hispanic population in millions can be modeled by the exponential function given below, where t equals 0 corresponds to 2000, and so that means this is going from 0 to 50, from 2000 to 2050. Use H to estimate the average rate of change. Ooh, did you hear that keyword? As soon as I hear that keyword average rate of change, I know I'm just finding the slope between 2 points. We want to find the average rate of change in the Hispanic population from 2000 to 2010. Let's go ahead and use our average rate of change formula then, our slope formula. So I know that I want to go from 2000 to 2010, or I can say t equals 0 to t equals 10. I can use my average rate of change formula, and I can do my y2 minus y1 over x2 minus x1, or t in this case, right? So if t equals 0, I can plug in a 0 into my function. T equals 10, I can plug a 10 into my function, and that's where I can get my y1 and my y2, or my h of 10 minus my h of 0. And then I have my x2 minus x1, or my t equals 10 and 0. Plugging in 10 to my function using my calculator, so you might want to pause your video, make sure you know how to enter this into your calculator correctly and get the same answers I do. But when I punched in a 10, I got 46.521 something. I just rounded it so I could write it down. And when I plugged in a 0, I got 37.791. Divided by 10, I'm going to go ahead and subtract the numerator. I get 8.73 and divide by 10. Now let's pause before we get an actual answer, and let's think about what our numbers represent, and let's put some labels on there, because I don't just want numbers, especially for doing an application problem. I want to know what that number means. Now remember, H represented the number of Hispanic population in millions. So that 8.73 is actually people, millions of people, right? And what did the 10 represent, the 0 and the 10? Well, the 10 represented the number of people per year. And so my labels should really be millions of people per year. So when I divide and I end up getting 0.873, that really means 0.873 million people per year. So what I'd like you to be able to do is write me a sentence. I'd like you to be able to write me a sentence including 3 things. What is happening? What is your answer? And what are the correct units? What does that answer mean? So in this case, we would say that the Hispanic population is increasing. Well, how did I know it was increasing? Well, because this is positive. I know then that the population is growing or going up. If it were negative, then I would say the Hispanic population is decreasing. So because my answer is positive, I know that the situation is going up, whatever it might be. In this case, the Hispanic population is increasing. So that's one key thing that I'd like you to be able to interpret in your sentence. The Hispanic population is increasing, on average, by approximately 873,000. That's the 0.873 million people per year. Or you can say 873,000 people per year. It means the same thing. I'm looking again for 3 things. What is happening? So it's increasing. By how much? And then what does it mean? So units. Increasing by 873,000 people per year. Average. Why don't you pause the video and try example number 2. Notice the key word, average rate of change. This time it gives you a graph instead of an equation, but you can still find the average, remember, by doing the slope between 2 points. Pause your video and then check your answers with mine. All right, when I found the average rate of change from 2009 to 2013, I did my y2 minus y1 over x2 minus x1, and I got an average of $0.545 billion per year, making sure that I'm looking at the graph and the information in the problem to label it correctly. So the 3 things in your sentence, the amount is increasing on average by approximately $545 million per year. Or you could have said $0.545 billion per year.